All right, you guys, we are back with our next type of exponential functions. All right, so element X is a radioactive isotope such that every 14 years its mass decreases by half. Given that the initial mass and sample of element X is 600 grams, write a function showing the mass of the sample remaining after t years, where the annual decay rate can be found from a constant in the function. Round all coefficients in the function to 4 decimal places. Also determine the percentage rate of decay per year. Okay. All right. So for these examples, we are going to use exactly the boxes, okay, that are here in delta math. So we've got f of t equals, we've got a box here, and then we have parentheses, we have a box here, and then we have an exponent. Okay, so we know that this is our initial amount. This is our rate. Okay, and this is our time. Because these problems they're slightly bit different in the way that what's happening to them is not, okay, it's different. It's different, okay, in terms of radioactive isotopes, and they only decrease by half, and it's only every 14 years. All right, so if I take f of t equals, okay, I start with a mass of 600 grams. Okay, all right, and every 14 years it decreases by half. So 0.5 is my rate, okay, because it's decreasing by half. All right, now here's where my time gets funky, okay? So it's got to be over a period of time, but it only happens every 14 years. So I'm going to divide by 14, okay? All right, so now what I got to do is I have to clean this up so that it can fit in the boxes, and I only have t here, okay? Because that's what Delta Math wants. I only have t right here. So watch what I'm going to do here. And this is where you got to know your exponent rules. So 600 times 0.5 or 0.5. Remember, this is 1/14th times t. Okay? And actually, I didn't mean you got to know your exponent rules. You got to understand what your fractions means. When you take t divided by 14, well, that's the same thing as taking, okay, 1/14th and multiplying it by t. All right, equals. So now I'm going to write 600, and now I'm going to write this in my calculator, type this in my calculator. So 0.5 exponent to the 1/14th. Okay, all right, so now that gives me 0.9517 to the t. Okay. All right. So now what that tells me now is I now have my yearly decay rate. Okay. So how much is my isotope going to decay each year? Okay. Whereas this equation was only set up to tell me, okay, that if I plugged in 5 years, okay, I had to do all this work to get my decay rate per year. Okay. Whereas now I know my decay rate. Okay, so how do I figure that out? Well, I don't do 0.95 minus 0.9517 minus 1 because I'll get a negative number. So I do 1 minus 0.9517 because it's decay. All right, so 1 minus 0.9517. That gives me 0.0483, which as a percent is 4.83%. Okay. All right. So now I'm going to go over here. I'm going to type that in 600 and then 0.9517 to the T. And now I have a decay. Okay. And it switched over to decrease. Okay. 4.83%. There we go. Okay. All right. So now Good luck with these problems. Okay, this is the one I wanted to show you. Be careful when they tell you every so many years, and I'm going to let you reach out to me if you need more examples. But between the first two videos and this one, I think you're good to go. All right, good luck.